Got air entering a diffuser operating at steady state. I'm given the inlet temperature and pressure and the velocity. I'm also given the ratio of the areas, the inlet and the outlet area, and I'm giving the velocity at the outlet. And I'm supposed to find T2 and P2. Tells me I can assume air behaves as an ideal gas. It also tells me that heat transfer is negligible. And the other assumptions that I'm going to make are the typical assumptions that I make for a diffuser. So we typically assume steady state, Q dots equal to 0, W dots equal to 0, and the change in potential energy is equal to 0. So the first thing that I need to do is apply my conservation of mass because I've got an open system and I need to relate those mass flow rates. So dm dt equals the sum of the m dots going in minus the sum of the m dots going out. And because it's operating at steady state, the dm dt goes away and I've got m dot 1 is equal to m dot 2. Then I apply my conservation of energy, which is my first law for an open system. dE dt equals all of this stuff. And of course, I'm assuming Q dots equal to 0, W dots equal to 0, and the change in potential energy, the GZ terms, are equal to 0. Or, well, the GZ is not equal to 0, but the delta GZ is equal to 0. And the dE dt goes away because it's at steady state. And so this is all I'm left with. And my conservation of mass tells me that m dot 1 and m dot 2 are equal to one another, so they divide out. And now this is all I'm left with. And what I'm going to do is I'm going to solve for H2 because that's going to help me find what T2 is. And so I need to look up what H1 is. So I look at my ideal air tables at T1, pull out that H1 value and just plug and chug. I do need to make sure that I pay attention to those units so that what I'm calculating is BTU per pound mass. Now that I've got H2, I need to look at my ideal air tables and look at the corresponding value for T2 at this enthalpy value. I'll have to interpolate, but I get a T2 of 569.7 degrees Rankine. Now I need to find P2, and for that I'm going to use my conservation of mass. So my conservation of mass tells me that m dot 1 and m dot 2 are equal to one another. And if I assume 1D flow, I can put those m dots in terms of area times velocity over specific volume. The way I'm going to handle the specific volume is I'm going to use my ideal gas law, so RT over P. And the next thing I'm going to do is I'm going to solve for P2. And if I kind of rearrange this, I see the R values cancel out, and I've just sort of like gathered the like terms together so that it's easy for me to just plug and chug and calculate what my P2 is. So there you go. I got T2, P2. I'm all done. Hope that was helpful. Thank you for watching, and let me know if you have any questions.